Today we are going to learn about a very important topic of class 11, that is states of matter. Okay, that is behavior of gases. Actually we have three different states of matter. Okay, but in this video we are going to learn about behavior of gases. Okay, now only about gaseous state we will be learning about in this video, and that too to some extent. Okay, each and every chapter will be made into two parts, and we will be discussing all the important points which are related to the topic, which will be helpful for you for EAMCET point of view, at the same time JEE mains and advanced as well. Okay, so I'll try to cover up all the points in the synopsis, whichever are there we'll be covering up, and at the same time if any numericals are to be done and which area has to be focused, everything will be discussed, as well as numerical part also. If you want, I request all of you to please keep giving comments like how I teach and what are the topics you want, and at the same time you want the topics in the form of bits or in the form of numericals, whatever it may be. If you can give me certain suggestions and comments, if you can give me, so that I'll try to modify myself and I'll try to give my best to my students to perform well in their competitive exams. Okay, all the children are getting ready to attend the crash course, okay, for EAMCET as well as JEE mains. Okay, EAMCET is going to be there, I think, in the second week of July, and in the last week of June itself you have JEE mains. Okay, so you have to make up your mind in such a way that I have to be prepared for the exams. Okay, already intermediate exams has been finished, but it's not at all the time to relax, dear children. Okay, it's time for you to focus more and more on your studies, and more exam tips and tricks you have to keep in your mind, so that you can definitely crack the EAMCET as well as other competitive exams like BITSAT, Olympiads, and whatever JEE mains, whatever competitive exams are going to be held ahead. Okay, so today we are going to learn about what? States of matter. That is our topic for today. Okay, those who are watching my videos for the first time, I request all of you to kindly visit my channel and don't forget to subscribe to my channel, and please keep giving comments. Your suggestions are most valuable for teachers like us. Okay, definitely will attend your doubts and all. Okay, so through this medium, and this platform is a very good platform for you as well as for the teachers to deal with the concepts very clearly. Okay, right, let us start with the topic. Today we are going to learn about what? States of matter. Okay, in this we are going to learn mainly about gaseous state. Okay, and that too some topics of gaseous state. So this will be a part 1 video. Okay, now video of part 1, right, dear children? Okay, so before we are going into the topic, actually we all know that we have three states of matter are there. From your childhood you are learning. What are those three states of matter? What are the three states of matter? Yes, solids, liquids and gases. Matter is something which has mass and occupies space. You all know that. So first state of matter, you all know, solids, and then liquids, and then gases are also there. Three states of matter are there. Okay, about solids and liquids you have a separate topics are also there for you in your intermediate class 12. Okay, now in this we are going to learn about gaseous state. Okay, other than these three states you have plasma state, and BEC is also present. Okay, plasma state, the fourth state of matter is what? Plasma state, which is considered to be what? Ionized gaseous state. Okay, now plasma state is a kind of ionized gaseous state. Okay, and then you have another matter is also there, which is called as excuse me, BEC. BEC stands for what? Bose-Einstein condensate. Okay, Bose-Einstein condensate. Okay, so this is also a kind of gaseous state of matter only, which is like a state of clouds. Okay, clouds in which water vapor is being included. Okay, at very low temperatures. Okay, gaseous state at very low temperatures, they can be called as what? Bose-Einstein condensate. Okay, right? And aurora, you know, or dawn of sun. Okay, during sunset. Okay, if you are finding clouds, okay, reflection can be seen from the clouds. Reflection of sunlight can be seen from the clouds, and slowly you will find all the clouds make the atmosphere to be dark. Okay, that situation you call it as aurora. Aurora is a kind of fifth state of matter, that is Bose-Einstein condensate. Okay, you don't have anything to do with these two states of matter. In today's topic, we are going to start about gases. Okay, so gases, what we call properties and all, you all know, isn't it? What are the properties of gases? General properties of gases. All the gas molecules move randomly in different directions. Okay, in straight lines. Okay, properties of gases, you know. Okay, gases are made up of what? Gases are made of tiny particles called molecules. Okay, now tiny particles called molecules. This you know. Okay, and all the gas molecules move in different directions. Okay, in straight lines. Move in different directions in straight lines. And you all know that gases exerts pressure in all directions. Okay, now they exerts pressure in all directions. Okay, gases exerts pressure in all directions, and gas molecules are having not having definite shape. They occupy the shape of the container, if you think. No, even if it is not like that also, gas molecules have the tendency to spread from one place to another place. So you have, in other words, a special term is being used which is considered to be the special property exhibited by gases, which is called as what? Diffusion. Gases undergo a property called diffusion. Diffusion means spreading of gas molecules from a region of higher concentration to a region of lower concentration, like spreading of smell of agarbatti, okay, or scent smell can be spreading from one place to another place, from a region of higher concentration to a region of lower concentration. You call it as diffusion. Okay, you have Graham's law is based on this property of diffusion. Okay, we'll be discussing about that also. Okay, and then you have a very special property of gas which is called as compressibility. Okay, compressibility. Gases undergoes the property of compressibility. Means what? Actually, compressibility is defined as the phenomenon in which decrease in the volume of same quantity of gas by the increase of pressure. You call it as what? Compressibility. Once again I repeat, I am not writing the definition here on the board because it is a crash course. As I upload each and every topic wise videos also will be available in the channel. Please visit my channel and kindly keep giving suggestions and your valuable comments. I'm keeping on saying, please check for the best videos in my channel, and please keep giving comments and your valuable suggestions, and don't forget to subscribe to my channel. Okay, so compressibility here, what is compressibility? Decrease in the volume of same quantity of gas by the increase of pressure. You are increasing pressure, the volume of gas decreases. That property you call it as compressibility, and based on this property of gases you have Boyle's law. Okay, so accordingly you have certain gas laws are to be read in this chapter. Okay, gas laws. So very important. I'm going directly into the topic, gas laws. Okay, very important gas laws you have, right? Gas laws. What are gas laws? Okay, each and by learning these gas laws, you can be very quickly you can identify and understand the importance and behavior of gases. Okay, through gas laws you have a lot much to learn about the measurable properties as well as physical properties exhibited by gases, right? So first we are going to learn about first law, which is called as what? Boyle's law. In gas law, first law is what? Boyle's law. So what does Boyle's law states? Okay, at constant temperature, the volume of a given mass of a gas is inversely proportional to pressure. Please understand the points carefully. At constant temperature, the volume of a given mass of a gas, volume of a given mass of a gas means volume of a fixed mass of a gas, given mass of a gas is inversely proportional to pressure. This is at what? At constant temperature. Inversely proportional means what? If one of the factors increases, the other one decreases. You are making a comparative study here. Inversely proportional to what? Inversely proportional to pressure. Okay, this is at constant temperature. So V is inversely proportional to P at constant temperature. This is called as what? Boyle's law. And mathematically you can express this as what? If you just remove the proportionality symbol which is there, can be replaced by an equality symbol by keeping a constant, isn't it or not? Proportionality symbol here can be replaced by an equality symbol. V is equals to some constant K into 1 by P. So if you cross multiply, you will be getting PV is equal to constant. PV is equals to K. This is called as what? Boyle's law. This is at what? Constant temperature. You can even write this as what? P1 V1 is equal to P2 V2, where initial conditions P1 V1 are the pressure and volume of a gas under initial conditions, and P2 V2 are the volume of gases under final conditions, or these may be the pressure and volume of two different gases also. You can take them in that sense also. Okay, so P1 V1 is equal to P2 V2. This is the mathematical expression for what? Boyle's law. Please understand carefully. This is at constant temperature. Okay, and please remember the graphs which are drawn at constant temperature are called as isotherms. Okay, what are isotherms? The graphs drawn at constant temperature. Okay, now the graphs drawn at constant temperature are called as isotherms. Drawn at constant temperature are called as isotherms. So graphical representation of Boyle's law if you take. Okay, now here I am writing. You please make a notes of what all being discussed in this class. Okay, request all the students to make a note. Okay, graphical representation of Boyle's law. Graphical representation of what? Boyle's law. Okay, so how you are going to represent Boyle's law in the form of a graph? Okay, so just look at this. Okay, so if you are taking pressure values on y-axis and volume of a gas on x-axis, you will be finding a descending curve like this at constant temperature. This is how graphically you can represent Boyle's law. Okay, or this can be even represented by taking, if you are taking pressure values on x-axis and 1 by V values if you take on y-axis, like as how now I am drawing here. If you take P on y-axis and 1 by V value if you take on x-axis, okay, as P and 1 by V are directly proportional to each other, you will be getting a straight line graph like this. Okay, now a straight line graph like this. Okay, or if you are going to take PV values, okay, PV values on y-axis and P or V values on x-axis. Okay, now PV value, directly PV is a constant value. Okay, PV value if you are taking on y-axis and here P or V value if you take on x-axis, then you will be getting straight line parallel to x-axis. Okay, now you will be getting a straight line parallel to x-axis. This is how Boyle's law can be represented graphically also. Okay, and if you take suppose log p and log v values on x-axis and y-axis, log p and log v values if you take, you will be finding a descending curve, descending straight line like this. So these all four are the representations of Boyle's law, and you will be finding definitely one compulsory question will be there based on the graphical representation of Boyle's law. Okay, 4 graphs will be given to you and you will be asked to find out the exact graph which represents Boyle's law. Okay, so any of the graphs may be given, or for more than one correct answer questions you will be given these graphs, so you have to choose 2 correct answers may be there. Okay, for more than one correct answer questions also you will be getting this kind of graphs. There is lot much scope to get one question based on the graphical representation of Boyle's law. Okay, so just remember and try to identify the graphical representation of what? Boyle's law. And these graphs are all these graphs are called as what? Isotherms. Please remember, right? So this is what you call it as what? Boyle's law. P1 V1 is equal to P2 V2. This is the formula for Boyle's law. Okay, next we will move on to the second law, that is, second law is what? Charles law. Charles law. So Charles law, what does Charles law tells us about? So Charles law, at constant pressure, volume of a given mass of a gas is directly proportional to temperature. Okay, and you have 2 different statements to express Charles law. Okay, what I said first one, at constant pressure. At constant pressure, okay, now volume of a given mass of a gas is directly proportional to temperature, absolute temperature. Okay, this is called as Charles law. Okay, so V is directly proportional to capital T. This is called as Charles law. You can express Charles law in other words also. See here, V and T are directly proportional to each other. Means if temperature increases, volume of a gas also increases. If temperature decreases, volume of a gas also decreases. But how much value it decreases or it increases? Okay, you have to understand this by second statement of Charles law. What does that second statement tells you? Yes, at constant pressure, the volume of a given mass of a gas increases with increase in temperature or decreases with decrease in temperature by a value of how much? 1 by 273 of its original volume. See, final volume if you take it as V, okay, initial volume if you take it as V naught, how much V naught will increase or decrease? See here, finally V becomes V naught plus V naught by 273. If for every 1 degree centigrade rise in temperature, that is also there. Okay, please understand the point carefully. At constant pressure, the volume of a given mass of a gas increases with increase in temperature or decreases with decrease in temperature. How much value it increases or decreases? By a value of 1 by 273 of its original volume. Okay, now 1 by 273 of its original volume, it will increase. If the temperature decreases by 1 unit, okay, then the volume decreases. Here you have to keep minus sign if it is the case of decrease in the temperature. Okay, then it decreases by a value of how much? 1 by 273 of its original volume it decreases. Okay, now for every 1 degree centigrade rise of temperature, increase will happen with rise of temperature and decrease will happen with decrease of temperature. If decrease in temperature is there, you have to keep minus sign here. If increase in temperature is there, you will keep plus sign there. Okay, so accordingly V is directly proportional to T at constant pressure. This is called as what? Charles law. Okay, so this can be even mathematically, you can represent this as what? V1 by T1 is equal to V2 by T2. This proportionality symbol you are replacing with an equality symbol by keeping a constant K. Okay, so here V by T is constant, is the mathematical representation for Charles law. So that only, in other words, we will write it as what? V1 by T1 is equal to V2 by T2. This is the formula which we will use for doing numericals based on this law. Okay, so this is about Charles' law, and even Charles' law can also be represented in the form of graph. So graphical representation of what? Charles' law. Okay, so here I am telling you that V is directly proportional to absolute temperature. Here you have to keep in mind that this law will be valid only if you take the temperature values to be in kelvins. You all know that there are different units to measure temperature. What are the different units? You have centigrade, Celsius, centigrade or Celsius scale is there. Okay, Fahrenheit scale is there, and Kelvin scale is there. Okay, so whatever the temperature which is being measured, it has to be measured in Kelvin, and that is why this Charles' law is useful to derive for the new scale of temperature, that is Kelvin scale. That's why you have to use the word absolute temperature here. Please understand the point carefully here. What does this absolute temperature word stands for? Okay, that can be understood by the graphical representation of Charles' law. So how you are going to represent graphical representation of Charles' law? How you are going to represent Charles' law graphically? Okay, so that can be understood like this. You just check this graph which is drawn between V and T. The variations are between what? V and T at constant, yes, at constant pressure. Okay, so here the graph look like this. Generally what we call we take volume on y-axis and temperature if it is taken on x-axis. Okay, you will find graph. Okay, now the graph of pressure graph means this graphs which are drawn at constant pressure are called as what? Isobars. At constant pressure, graphs drawn are called as isobars. So you will find this isobar graph cuts the negative x-axis. Okay, now cuts the negative x-axis at minus 273 degrees centigrade. Okay, please understand the point carefully. This is at what? Constant pressure. At constant pressure. Okay, so here this graph cuts the negative x-axis at minus 273 degrees centigrade. Okay, this temperature is called as what? Absolute zero of temperature. Absolute temperature means the one which is to be measured in Kelvin. Please understand the point carefully. Here I am using another new word, that is absolute zero of temperature. Why I am using the word zero again here? Okay, so what is absolute zero of temperature? Means the temperature at which the volume of gas molecules becomes zero. At the same time, kinetic energy of the gas molecules becomes zero. That means the intermolecular forces that are existing in between the gases totally becomes zero. Kinetic energy of the gas molecules becomes zero. Okay, so that temperature you call it as what? Absolute zero of temperature. Absolute zero. Okay, so what is that absolute zero of temperature? The temperature at which the volume of the gas molecules becomes totally zero. The volume of the gas molecules becomes zero. Not only volume, even kinetic energy of the gas molecules becomes zero. Ke of the gas molecules. Okay, now Ke of the gas molecules becomes what? Zero. That means there is no movement of gas molecules at this temperature. Okay, so that temperature is called as what? Absolute zero of temperature, and that value is equal to what? T is equal to minus 273 degrees centigrade, which is equal to what? 0 Kelvin. 0 degrees Kelvin. Minus 273 degrees centigrade is called as what? 0 Kelvin. In Kelvin scale, if you are asked to convert the temperature which is given in degrees centigrade, if you have to convert it into Kelvin, you have to add 273. Okay, like you 1 degree centigrade is how many Kelvin? 1 plus 273 is 274 Kelvin. Please understand, 1 degree centigrade is equal to 1 degree centigrade is equal to how much? 274 Kelvin. So whenever you are doing numericals based on Charles' law, if the temperature is given in degrees centigrade, you have to convert it into Kelvin, and then accordingly you have to solve that numerical. Okay, so please remember, and this temperature is called as what? Absolute zero of temperature. Okay, so these are the graphs which are drawn at constant pressure are called as what? Isobars. Please remember, this is the graphical representation of what? Charles' law. Okay, next we will be moving on to the third law, that is Gay-Lussac's law. Gay-Lussac's law of combining volumes. Okay, so Gay-Lussac's law. Third law is what? Gay-Lussac's law. So what does this law states? So at constant volume, please understand the point carefully. At constant volume, pressure is directly proportional to temperature. At constant volume, P is directly proportional to what? Temperature. This is called as what? The statement for Gay-Lussac's law. Gay-Lussac is the name of the scientist. P is directly proportional to T. Proportionality symbol, you are going to replace it with inequality symbol by keeping a constant K. So P is equal to K into T, or P is equal to KT, or in other words, P by T is equal to constant. In other words, you can write even this as what? P1 by T1 is equal to what? P2 by T2. This is the mathematical representation for what? Gay-Lussac's law. Okay, this is at constant volume, and the graphs which are drawn at constant volume are called as what? Isochores. Please remember, the graphs which are drawn at constant volume. Okay, now the graphs drawn at constant volume are called as what? Are called as isochores. Okay, now isochores. The graphs drawn at constant volume are called as what? Isochores. Please remember. Okay, so isochores are the graphs drawn at constant volume. Please remember, and this is what you call it as Gay-Lussac's law. Okay, then we will move on to the very important law which is called as what? Avogadro's law. Avogadro, you have learnt about Avogadro's number in stoichiometry. Okay, so number of moles. Avogadro's number will tells you about the number of particles which are present in 1 mole of a substance. You call it as Avogadro number. Okay, and that number is equal to what? 6.023 into 10 to the power of 23 particles will be present in 1 mole of any substance. Okay, just recall Avogadro's number. So the fourth law which we are going to proceed is what? Avogadro's law. So what does this Avogadro's law states? Okay, so Avogadro's law states that under similar conditions of temperature and pressure, equal volumes of all gases contains equal number of molecules. This is the statement for Avogadro's law. Okay, what I said, at constant temperature and pressure. At constant temperature as well as pressure. Here both are constant. Okay, equal volumes of all gases contains equal number of molecules. Equal volumes of all gases contains equal number of molecules. This is the statement. Okay, now equal number of molecules. This is the statement for what? Avogadro's law. Equal volumes of all gases contains equal number of molecules. Means what? Here the volume of a given mass of a gas is directly proportional to number of moles at constant temperature and pressure. Okay, that is what the statement means. Okay, at constant temperature and pressure, what is directly proportional to what? Volume is directly proportional to N. N stands for what? Number of moles. Okay, now V is directly proportional to N. Okay, V is directly proportional to N. This is Avogadro's law. Here you are replacing the proportionality symbol can be replaced by an equality symbol by keeping a constant N, K, or V by N is equal to constant, or in other words V1 by N1 is equal to what? V2 by N2. This is the mathematical representation for what? Avogadro's law. Okay, now this is the mathematical representation for Avogadro's law. Okay, so now based on this Charles law, Boyle's law and Avogadro's law, you have ideal gas equation is also there. Okay, so what is ideal gas equation? I am going a little bit faster, dear children, because it's like a crash course. We are uploading the videos. Okay, now the videos are being uploaded only based on the crash course, because within short time how much more you can learn. Okay, that's why the whole topic is being revised in 2 parts of each topic. Okay, please understand the concepts carefully, keep writing and copy whatever the topics which are being discussed in the video. Please make a note of all those points and maintain your own notes. Okay, the more you write and practice, the best will be your conceptual understanding. Okay, so please follow that concept. So here ideal gas equation, what is meant by that ideal gas equation? You will be getting ideal gas equation by combining 3 laws. Okay, now you have Boyle's law, that is volume is inversely proportional to pressure. This is at what? Constant temperature. This is called as what? Boyle's law. You know that, right? Boyle's law. Similarly, volume is directly proportional to temperature at constant volume, at constant pressure. This is what? Charles law. And if you consider this Avogadro's law, okay, volume is directly proportional to N. Okay, at constant volume is directly proportional to N at constant temperature as well as pressure. Okay, now at constant temperature as well as pressure, and this you call it as Avogadro's law. So if you are combining these 3 laws, okay, now by combining these 3, this is 1, this is 2 and this is 3. Combining 1, 2 and 3, you will be getting what? Combining 1, 2 and 3. What you will get? V is directly proportional to 1 by P into T into N. Okay, now so that implies NT by P. NT by P. Okay, so if you just replace this proportionality symbol by an equality symbol, you will be keeping a constant every time. Every time what we do, proportionality symbol can be replaced by an equality symbol by keeping a constant. Here by combining the 3 laws, okay, now V is directly proportional to NT by P we got by combining the 3 laws. Okay, proportionality symbol you are replacing with an equality symbol by keeping a constant R, okay, into NT by P. So accordingly, if you cross multiply, PV is equal to nRT. Here R is called as what? Universal gas constant. Okay, now universal gas constant. R is called as what? Universal gas constant. And this universal gas constant will have several values depending on their units. Okay, now if you take units in like in SI units, if you take, you will have one value. If you take CGS units, you will have another value. Okay, like that R value changes with units. Okay, so if you come across R here, PV by NT you have to take. Okay, now if you take the units of pressure, okay, if you go for the units of pressure are what? Atmospheres. And the units of volume are what? Liters. Okay, and units of N means what here? Number of moles. So units of N are what? Moles. And units of temperature are Kelvin. Okay, so liters atmospheres per mole Kelvin, okay, are the units for R. Okay, so in this units, R value is equal to 0.0821 liters atmospheres per mole Kelvin. Okay, now remember the units, liters atmospheres per mole Kelvin. If you take the units to be joules per mole Kelvin, R value can be 8.314 joules per mole Kelvin. Okay, or if you take the R value in calories, it can be 1.987, or most of the times Okay, we will take it as a 2 calories per mole Kelvin. Okay, calories per mole Kelvin. R value can be even take it as what? R is equal to 2 calories per mole Kelvin. Okay, now so these are the units to measure R, and R is called as what? Universal gas constant. Okay, so this very important point regarding ideal gas equation. Okay, just take a screenshot or pause the video, make a note of all the points which we have discussed, and please keep writing and practicing. Okay, then we'll move on to the next law, which is called as Graham's law of diffusion. I just told you diffusion is a very important property of what? Very important property of gases, in which gas molecules have the tendency to spread from a region of higher concentration to a region of lower concentration. Okay, homogeneously gas molecules will spread. Okay, so that procedure you call it as diffusion. Okay, so next I think this is fifth law, which is called as what? Graham's law of diffusion. Okay, now Graham's law of diffusion. So what does this Graham's law states? This is also under similar conditions of temperature as well as pressure. Okay, the rate of diffusion of a gas is inversely proportional to the square root of its density or square root of its molecular weight. Okay, what I said? Under similar conditions of temperature and pressure. Please understand the statement. So accordingly you will be getting the mathematical expressions. Without understanding the statement, it is very difficult for you to write the mathematical expression, and simply by hearting may make wrongs. Okay, you may make mistakes if you just by heart a formula for Boyle's law. Okay, if you understand the statement for Boyle's law, then accordingly you will be getting the mathematical expression also. If you are just by hearting without understanding the concept, it is very difficult for you to get on to the topic. Please do not by heart. Okay, try to understand the topic as completely as possible. Try to absorb all the concepts as completely as possible, and accordingly you try to present the mathematical expressions for each and every law. Okay, so under similar conditions of temperature and pressure, under similar conditions of what? Temperature and pressure. Okay, rate of diffusion of a gas is inversely proportional to square root of its density. Okay, now square root of its density, or R is inversely proportional to what? Square root of density of the gas, or even you can write it as R is inversely proportional to square root of molecular weight of the gas. Okay, now square root of molecular weight of the gas. This is the main statement for Graham's law of diffusion. Rate of diffusion of a gas is inversely proportional to square root of density or inversely proportional to molecular weight, square root of molecular weight. Okay, so this is the statement for Graham's law of diffusion. Okay, you can even write like this also. R is inversely proportional to square root of density, which means R1 by R2 is equal to square root of D2 by D1. You can write even like this. Okay, now R1 by R2. Here R is a rate of diffusion. Please remember, R1 by R2 is equal to what? Square root of D2 by D1. That can even also be written as what? M2 by M1. Okay, so like this also you can represent what we call Graham's law of diffusion. Okay, R1 by R2 is inversely proportional to D2 by D1. Okay, so this is the representation for mathematical representation for Graham's law of diffusion. Okay, so Graham's law of diffusion can be used for what? For identifying the process of diffusion. Means to identify the release of poisonous gases in coal mines. Okay, in coal mines, poisonous gases like methane, okay, are going to form, right? So such kind of like gases Okay, any leakage of gases or anything, if they are there, okay, you will be finding easily, because gases have the tendency to spread from a region of higher concentration to a region of lower concentration, right? Okay, fine. Now coming to the next law, which is called as what? Dalton's law. Okay, now Dalton's law of partial pressures. Next law, sixth law, is a very important law, that is Dalton's law of partial pressure. Okay, Dalton's law of partial pressures. So in the name itself it is there. Okay, if two or more non-reacting gases, what does this law states? Okay, if two or more non-reacting gases, you have to remember this word very carefully. If two or more non-reacting gases are enclosed in a container, mixture of gases are there in a container, then the total volume of that gaseous mixture, or the total pressure of the gaseous mixture, is equal to sum of partial pressures of each component of a gas. Please understand the points carefully. Okay, if two or more non-reacting gases, two or more non-reacting gases, two or more non-reacting gases are enclosed in a container. Okay, now if two or more non-reacting gases are enclosed in a container, then okay, then what happens? Then okay, what we call total pressure of the gaseous mixture, total pressure of the gaseous mixture is equal to sum of the partial pressures of each component of a gas. Total pressure of the gaseous mixture, okay, now total pressure of the gaseous mixture is equal to what? Is equal to sum of the partial pressures of each component of a gas. Okay, now sum of partial pressures of each component of a gas. This is called as Dalton's law. Is equal to what? Sum of the partial pressures of each component of a gas. Okay, now sum of partial pressures of each component of a gas. This is called as Dalton's law of partial pressures. Okay, so P total is equal to what? P1 plus P2 plus P3 and so on. If P1, P2, P3 are partial pressures of each component of a gas. Okay, now, right? So this is called as what? This is called as Dalton's law of partial pressure. Okay, so you can take partial pressure of any gas is equal to total pressure into mole fraction. Partial pressure of a gas, partial pressure of a gas is given by the formula total pressure into mole fraction. Okay, now total pressure into mole fraction. Okay, mole fraction means what? It is the ratio of number of moles of one of the components to the total number of components of all the gases present in the mixture. What is mole fraction? Suppose XA, you will denote it by psi A. A is first component of a gas, is equal to what? Na by Na plus Nb. This is called as mole fraction of that component A, which is present in the gaseous mixture. And what type of gases it is applicable? This law is applicable only if two or more non-reacting gases are present in the container, then only this law is applicable. Please remember that point also. Here XA, you will read it as psi A. Okay, now XA, you will read it as what? Psi A is equal to what? Na by Na plus Nb. Or if it is second component, you will write it as XB, or psi B is equal to what? Nb by Na plus Nb. And you all know that sum of the mole fractions of each component is equal to unity. Okay, XA plus XB is equal to 1 always. You generally read it as X, but you have to read it as what? psi, psi A, xi. Okay, now chi or xi, xi. You will read it as what? Xi, chi, xi. Okay, or chai, whatever it may be. Some people will pronounce in different ways. Okay, so partial pressure of any gas is equal to what? Total pressure into mole fraction. Based on this formula, you will be having numericals. Based on what? Dalton's law of partial pressures. Right, and next we have kinetic theory of gases, and you have what? Kinetic gas equation. I am not dealing in this video, I am not dealing very elaborately, because it's like a crash course. You have to go with the topics one after the other. Okay, quickly. Okay, because you have lot many things to learn. So go with the crash course. Okay, and try to learn the topics as quickly as possible. Right. So kinetic theory of gases will be there. In that you have kinetic gas equation. Everybody knows that. What is kinetic gas equation? Okay, now it's not I'm not uploading the video for for IP children. It is for crash course. So I'm not dealing with kinetic theory of gases. You will not be getting any theory questions in EAMCET, isn't it? So kinetic gas equation. So what is kinetic gas equation? You all know that PV is equal to 1 by 3 mn c square. Here P is pressure, V is volume, you all know that, and M is mass of gas molecules, N is number of moles, and C stands for root mean square velocity. Again ma'am is telling new word for us. No, it's not a new word, you have learned already all these topics, that's why I am going a little bit faster. Right, dear children? Right, here C stands for what? Root mean square velocity. Okay, now you have different velocities are being possessed by the gas molecules. Root mean square velocity. Okay, so you have three types of velocities. Distribution of molecular velocities is there. Okay, now distribution of molecular velocities, different types of molecular velocities. Okay, so this equation you call it as what? Kinetic gas equation. You have to remember this. Okay, and different types of molecular velocities. What are those? Different types of molecular velocities. What are the different types of molecular velocities? Okay, so you have three types of molecular velocities are there. First one is called as RMS velocity, which is called as root mean square velocity, and the second one is called as most probable velocity, and the third one is called as average velocity. You have three types of velocities are being possessed by the gas molecules. Three types of different types of molecular velocities. Gas molecules possess different types of velocities. Okay, three types of velocities they are being exhibited. One is RMS, second one is most probable, and the third one is average velocity. Okay, you have to remember the formulas based on these RMS as well as most probable and average velocities. What are the formulas related to the three types of velocities? That formulas you have to remember. Okay, so what is the formula for root mean square velocity? Okay, different types of velocities, as I said, you have three different types. Root mean square velocity, what is the formula? As just now you have here kinetic gas equation is there. If you just cross multiply, okay, RMS velocity, first one is what? RMS velocity, you have 3 PV is equal to mn c square. If you take c square, it is equal to what? 3 PV by mn. Okay, mn. For 1 mole of a gas, you can take n value to be 1. Okay, so c value if you want, it is equal to what? 3 PV by mn. Okay, 3 PV by mn. Okay, or if you take it for 1 mole of a gas, you will take here molecular weight of a gas. Okay, molecular weight of this gas. If you take for 1 mole, mn is equal to what? Capital M. Okay, so that can be replaced as what? 3 PV by capital M. Okay, suppose if you take it for 1 mole, in place of PV, you can even write it as what? RT also, because PV is equal to RT. According to kinetic gas, ideal gas equation, PV is equals to nRT. Here n value, if you take it as 1, you can take PV is equals to RT for n is equal to 1. Okay, so you can even write the formula for RMS velocity as what? 3RT by m 3 PV by m. Okay, here volume by mass can be even written as what? Density. Okay, so you can write even another formula 3P by D, because D is equal to what? Mass by volume. Here volume is in the numerator and mass is in the molecular mass. This is molecular mass is in the denominator. So density is in reciprocal condition. So 3P by D. You can even write the formula for root mean square velocity as what? 3RT by m, 3P by D, or 3PV by m. So this is called as root mean square velocity. Okay, and the same like that you have the formula for what? Most probable velocity. The formula for most probable velocity. What is the formula? Second type of molecular velocity is what? Most probable velocity. Okay, so here same like 3PV by mn, you have directly remember the formula for most probable velocity. It is the velocity possessed by maximum number of gas molecules. Most probable velocity. For this same formula like RMS velocities. Okay, so here it is represented by Cp is equal to what? 2PV by m. Instead of 3PV, you will be taking it as what? 2PV by m. Okay, square root of 2PV by m. 2RT by m. PV can be written even as what? RT. So 2RT by m. Okay, V by m can be even written as density, reciprocal of density. So you can even write it as 2P by D. So this is the formula for most probable velocity. And finally the third one is there. Okay, you have third one is average velocity. You have the formula same like the previous two. You have to remember the formulas only for doing numericals. Okay now, so average velocity. What is the formula for average velocity? And you are going to represent it with C bar is equals to root 8 RT by pi m. Please remember the formulas. 8 RT by pi m, and that can also be written as 8 PV by pi m, that is equals to 8 P by pi D. This is the formula for what? Average velocity. Okay, so like this you have three types of molecular velocities are there, and accordingly you have the conversions are also there. Mostly you will be asked about the ratio. C RMS is to C most probable is to C average. Okay, for this ratio will be asked, molecular ratios, okay, of molecular velocities. 1 is to 1.128 is to 1.224 is the ratio. Please remember this ratio. Okay, ratio of RMS, what we call most probable, and average velocities. 1 is to 1.128 is to 1.224 is the ratio of the three velocities. Okay now, so this ratio also you have to remember. So accordingly you will be having certain conversions are also there, that is also very much important. So this is regarding the first part of this lesson, gaseous state. And in the second part you will be learning about what? You will be learning about ideal behavior of gases, non-ideal behavior, van der Waals equations, and critical phenomenon, liquefaction of gases. Regarding that concepts you will be learning in part 2. Okay, in second part of the video I am going to upload that for the next concepts of gaseous state. Okay, okay, now we will be doing certain numericals based on the concepts of what all we have discussed. Okay, so let us move on to the very important numericals which will be focused for EAMCET point of view. Okay, so let us do that numericals. You just take down the questions like this and you have to answer these questions, please. Numericals based on the concept. Okay now. Okay, the conceptual based, these are very important for exam point of view. So let us go for the first one. A sample of a gas has a volume of 0.2 liters. Okay now, a sample of a gas has volume how much? Has volume of 0.2 liters. Okay, at 1 atmosphere pressure. At 1 atmosphere pressure. Okay, at same pressure, but at 273, at same pressure, the question is what? At same pressure and at 273 degrees centigrade, and at 273 degrees centigrade, its volume will become how much? Its volume will become how much? Its volume will become dash. So options are given 0.6 liters. Okay now. Option B is 0.4. Option C is 0.2. Option C is 0.8. So here what is given? A sample of gas has volume. Volume is given 0.2 liters. Okay now. So V1 we will take it as 0.2 liters L. Okay. And at 1 atmosphere pressure. Here it is given that at same pressure. That means pressure is constant here. That means you have to use which law? Yes, you have to use Charles' law. Okay. So if constant pressure is there, okay, volume you have to find. Final volume you have to find. Okay. And what is the temperature? Volume of 0.2 liters at 1 atmosphere pressure. And at same pressure at 273 degrees centigrade, its volume will become how much? Okay, 0.2 liters is the V1. Okay, and T1 is how much? 0 degrees centigrade. Okay now, 0 degrees centigrade at 1 atmosphere pressure. Okay, volume will be how much? That is at STP. At STP, the volume temperature will be 0 degrees centigrade, which is equal to how much? You have to take always temperature in kelvins. Okay now, 273 Kelvin. So V1 is 0.2, T1 is 273 and V2 is, you have to find, T2 is given as 273 degrees centigrade. Means you have to add 273 to convert it into Kelvin. Okay now, so 273 plus 273, which is equal to what? 546 Kelvin. Now according to Charles' law, okay, what is the formula for Charles' law? Just recall, V1 by T1 is equal to what? V2 by T2. Okay, so you have to find V2 here. V1 is given 0.2 by T1 is 273. V2 you don't know, so you will keep it as V2 only, and T2 is 546 Kelvin. Okay now, T2 is how much? 546. So in this, if you cut this with 273 ones are and 2s are, that means 0.2 by 1 is equal to V2 by 2. That means V2 is how much? Just cross multiply. V2 is equal to 0.2 into 2, which is equal to what? 0.4 liters. So final volume is how much? 0.4 liters. So answer is what? B. So you have to use which law here? Charles' law. Okay. So if you want, please pause the video for a little time. Please note down. These are all the EAMCET examination questions only. Previous questions which mostly come across. Okay. So we'll move on to the next question. Second question. You just look at this graph. A graph is given like this. Question number 2. Okay, one graph is given like this. Okay, which is drawn between volume on x-axis and temperature on y-axis. Okay, so the graph is given here, temperature is given 300 and here temperature is given 600 Kelvin. Okay, and here temperature is given volume is given 20 liters and here it is given 40 liters, and a graph is given like this. Okay, in between 20 and 40 a graph is given like this. Okay, so now you have to identify. Now the question, what is the question given? The graph is given like this and the question also given like this. The following graph indicates the system containing, question is like this. The above graph, what is the question? The above graph indicates the system containing 1 mole. The above graph indicates the system containing 1 mole. Okay, system containing 1 mole. 1 mole of a gas involving various steps. 1 mole of a gas involving various steps. Okay, now involving various steps. Okay, so what is the question given? When it moves from Z to Y, see, look at this graph, it is given like this, and at 40 you have drawn a line like this. Even at 300 Kelvin you have drawn one line, at 600 Kelvin you have drawn one line. Okay, suppose if you just add this, okay, and he has given not here, just you were given alphabets like this. X, here X is given, here Z is given, and here Y is given. Okay, and arrows are given like this. Okay, so here this gaseous system is involving various steps, it seems. Okay, when it moves from Z to X, when it moves from Z to X, that means the curve when it is moving from Z to X, just note down the question. That's why I am writing even the question also. Okay, so please note down the question also. When the graph is moving, when it moves from Z to X, okay, now from here to here, from Z to X, okay, when it moves from Z to X, the type of process that is undergoing is dash. The type of process that is undergone by the gas, undergone by the gas is dash. That is the question. Here options, 4 options what were given? Once check the 4 options: cyclic, isothermal, isochoric, isobaric. Option A cyclic, option B isothermal process, isothermal, option C isochoric, option C is what? Isochoric, and option D is isobaric. Like this question is given. Okay, so you have to identify. The graph indicates which process among these 4 options. Okay, so what you will do here? See, first at X, what is the temperature and what is the volume? See, gas at X. Solution I am doing here. Once check. Gas at X. Okay, so I am taking for X T1 and V1. V1 volume is 20 liters and T1 temperature is 300 Kelvin. Okay, now 300 Kelvin. Similarly, gas at Z. He is asking in the question Z to X, isn't it? So gas is at Z. What are the values at Z? V2. We will take volume as V2. V2 is 40 liters. Okay. And T2 is how much it is given? Yes, 600 Kelvin. T2 is given as 600 Kelvin. Okay, now, so the conditions for gas X, V1, T1. Conditions for gas Z, V2, T2. Okay, so now you have to identify which measurable property is maintained constant here. Okay, so according to combined gas equation, let us use here, we don't know which gas law has to be used. Then what we will do? We will go for what? Combined gas equation. Okay, now we will go for combined gas equation. Okay, I am rubbing this graph. Please take down the graph, dear children. Okay. Yes. Pause the video, take down the graph, and then try to answer the questions. Okay. Now what law we will use? We don't use any law here. We will use combined gas equation. Okay, now here what is combined gas equation? According to combined gas equation. Okay, now according to combined gas equation, P1 V1 by T1 is equal to what? P2 V2 by T2. Let us substitute what all the values which we know. We'll substitute in this combined gas equation. P1 V1 by T1 is equal to what? P2 V2 by T2 is called as combined gas equation. We don't know the pressures. Okay, so P1, P2 we will keep them as it is. Okay, now we don't know, pressures are not given in the question. So P1 and P2 like that only we will keep. Okay, so P1 as it is we were keeping. V1 is 20. So P1 into 20 by T1 is how much given, dear? 300 is equal to P2 into V2 is given how much? 40 by T2 is given 600. Okay, here 0 0 gets cancelled, here 0 0 gets cancelled. 2 by 30 into P1. This can be written as 2 ones are 2, 2 15s are 30. Here also 4 ones are 4, 4 15s are 30. 60, sorry. 4 15s are 60. So P1 by 15 is equal to how much you got? P2 by 15. That means here denominators are equal. Okay, now here denominators are equal. So you can go for what? Numerators also you can make it equal. So P1 is equal to P2. You got this condition. Okay, so if pressures are constant, okay, what are those graphs are called as? If pressures are constant, the graphs drawn at constant pressures are called as what? Yes, the graphs drawn at constant pressures are called isobars. So answer is what? Isobaric. So this way they will be asking the question. Please take down. Very, very important question this is. Okay? Yes. So way of questioning will be like this in your EAMCET examination. Okay? Yes. Now let us move on to the third question. Okay? Let us go for the third question. What is question number 3? Yes. Okay. So take down question number 3. Which gas has a density of 1.4 grams per liters at 0 degrees centigrade and 1 atmosphere pressure? See here, question number 3 is what? Which gas among the following? Which gas among the following? Which gas among the following will have density? Will have density is equal to how much given? Will have density equal to 1.24 grams per liters, it seems. 1.24 grams per liters. Okay. At what temperature and pressure? At 0 degrees centigrade. At 0 degrees centigrade and 1 atmosphere pressure. This is your question. Options are given like this. You have to choose which gas is having that density. Options are O2, CH4, CO and CO2. O2, CH4, CO, carbon monoxide and CO2. You have to identify which gas is having 1.24 grams per liters of density. Okay, to find density, what formula you will use? Okay, see here, solution let us do. Here temperature is given how much? 0 degrees centigrade. Okay, now temperature is 0 degrees centigrade and pressure is 1 atmosphere. These two conditions are meant for which state? Yes, STP conditions, standard temperature and pressure conditions. These two are what? STP conditions. Okay, now STP conditions. So under STP conditions, you know volume also equal to how much? Did you remember? Under STP, at STP, standard temperature and pressure, volume is given how much? Volume will be how much? Volume of any 1 mole of any gas is equal to how much? 22.4 liters. Yes, very good. 22.4 liters of volume. The gas will occupy 22.4 liters of volume at what? STP conditions. Just recall this value. Okay, why we are going for volume here? Density means mass by volume. Okay, now. Okay, so mass by volume should be equal to 1.24 it seems. So you have to find the densities of all the gases which are given in the 4 options. Okay, just check with the option A to find the density of oxygen. Okay, mass by this volume you have to take. Okay, molar mass of O2 is how much, dear children? 32. Okay, volume is 22.4. V is 22.4. So density of oxygen gas, I am writing here DO2 is equal to how much? Mass by volume. So 32 by 22.4. If you simplify this, 32 by 22.4, you will get 1.428. 1.428 grams per liters. He is asking for what? 1.24 grams. That gas should have density 1.24 grams. Okay, but for oxygen, which is given in the first option, oxygen, how much density we got? 1.42 we got. So option A is what? Ruled out. Okay, now you have to check answers from the options which are given to you. Okay, from the options which are given, we have to check for the answers. Okay, so check with the second option. What is second option? For CH4, molar mass is how much? Molar mass for methane gas is 16 grams, isn't it? So density is density of CH4 is equal to dCH4. How much you will be getting? Mass by volume. 16 by volume is 22.4 liters. If you simplify this value, 16 by 22.4, you will be getting 0.72. Okay, now 0.716. Okay, grams per liters. So this option is also ruled out. He is asking in the question for how much is the density? 1.24 you should get. For O2 we got 1.428. For CH4 we got 0.716. Okay, for third option you have to go for CO. Okay, now for CO, how much is the molar mass, dear children? Carbon 12, oxygen 16. So it is 28 grams. Density dCO2 is equal to how much? 28 by 22.4. This value will be equal to 1.246 grams. So this answer is correct. Means answer C. Answer is C. You can even check for CO2 also. For CO2 molar mass is how much? 44 grams. Density means mass by volume. dCO2 is 44 by 22.4, which will be equal to almost around 1.96. So this option is ruled out. Okay, now grams per liters. So correct answer is what? This one. Density of CO, not CO2 here, CO. Density of CO. So it is equal to 1.24. So answer is what? C, means option C. Carbon monoxide is having 1.24 grams per liters of density. That is your third question. Okay. So please take pause your video and take a screenshot of this, or okay, write and practice. Request all of you to please kindly note down what your teacher is saying. Right? We'll go for the fourth question. What is fourth question? Question number 4. Okay, at STP, 0.48 grams of O2 diffused through a porous pipe. See here, question number 4. Diffused. The word diffused is used. Means which law you have to use? Graham's law of diffusion. Yes, very correct. Okay, fourth question is what? At STP, 0.48 grams of O2. At STP, 0.48 grams of O2 is diffused. Okay, now I am writing the question also for your sake, so that you will be understanding properly. Diffused through porous pipe in 1200 seconds, it seems. Diffused through porous pipe in 1200 seconds. Okay, now oxygen diffused through a pipe, okay, through a small opening or through a small hole, it is going out. Okay, diffused means what? It is going out. Okay, in how much time? 1200 seconds it has got diffused, it seems. Okay, what volume of CO2 will diffuse in the same time under same conditions? Now question is what? What volume of CO2 will be diffused? What volume of CO2 will be diffused under same conditions? That is the question. Under same conditions. What volume of CO2? Here diffusion of CO2 is given as 1200 seconds. Okay, 0.5 grams, 0.48 grams is given. Okay, so how you will do? You are asking to find the volume of CO2. Okay, here this 0.48 is what? That many grams of oxygen goes out in 1200 seconds. Now our question is, how much volume of CO2 will diffuse if such is the case with oxygen? Okay, once listen. So many children are asking me to explain in Telugu also. Okay, see here. If oxygen is 0.48 grams of oxygen is diffusing in 1200 seconds, how much volume of CO2 will diffuse in same time? That is the question. Okay, so what you will use here? You will use Graham's law of diffusion. Okay, so let us do. Here he is asking for volume. To find the volume, okay, volume for 1 mole of a gas, you know it is how much? 22.4 liters. Okay, but here moles not given, grams given. So you have to find moles. First you have to find number of moles of oxygen. Okay, and for that moles, how much will be the volume? You have to calculate volume in that way. First what we will do? Number of moles we will do. Okay, now number of moles of oxygen. How much you will be getting? Number of moles, you have what formula? Given weight by gram molecular weight. Given weight is 0.48 by molar mass of oxygen is how much, dear children? 32. Okay, this many moles of oxygen is diffused, not volume, moles. Please understand. Okay, you know, we know that. What you will write here? We know that 1 mole of any gas has how much volume? 1 mole of any gas has 22.4 liters. Okay, then 0.48 by 32. Okay, now 0.48 by 32 moles of O2 has how much volume? You calculate that. Okay, 1 mole has how much? 22.4 liters. Now number of moles in oxygen you got how much? 0.48 by 32. You need not to simplify. Leave it like that only and directly continue with the problem. Okay, 0.48 by 32 into 22.4. So if you take this as x is how much? 0.48 by 32 into 22.4 liters. Okay, so volume of oxygen diffused is how much? Volume of oxygen diffused is 336 ml. Okay, if you are getting it in liters, 22.4 liters you will take. If you take it in ml, grams, see here, units of weight are given in grams. గ్రామ్స్లో తీసుకుంటే వాల్యూమ్ లీటర్స్లో మిల్లీ లీటర్స్లో తీసుకోవాలి. కేజెస్లో వెయిట్ తీసుకుంటే వాల్యూమ్ యూ హ్యావ్ టు టేక్ ఇన్ లీటర్స్. ఇక్కడ ఏంటి గ్రామ్స్లో ఇచ్చాడు. సో హియర్ యూ హ్యావ్ టు టేక్ వాల్యూమ్ ఇన్ మిల్లీ లీటర్స్. ఓకేనా, యూ హ్యావ్ టు టేక్ హియర్ వాల్యూమ్ ఇన్ వాట్, మిల్లీ లీటర్స్. సో ఇంటూ 22,400 ml. If you simplify this, you will get how much? 336 ml of oxygen. సో ఎంత వాల్యూమ్ ఆఫ్ ఆక్సిజన్ డిఫ్యూజ్ అయ్యింది లీటర్స్లో, లేకపోతే మిల్లీ లీటర్స్లో, వాల్యూమ్లో ఎంత ఆక్సిజన్ డిఫ్యూజ్ అయ్యింది? 336 ml. ఓకేనా, సో దిస్ ఈజ్ ఆక్సిజన్. ఓకే, ఎంత టైంలో డిఫ్యూజ్ అయింది? 1200 సెకండ్స్లో. అంటే రేట్ ఆఫ్ డిఫ్యూజన్ కావాలి ఇప్పుడు మనకి. ఓకేనా, యూ హ్యావ్ టు ఫైండ్ వాట్, రేట్ ఆఫ్ డిఫ్యూజన్. చూడండి, ఆర్, రేట్ ఆఫ్ డిఫ్యూజన్ ఆర్ ఈజ్ ఈక్వల్ టు వాట్, వాల్యూమ్ ఆఫ్ గ్యాస్ డిఫ్యూజ్డ్ బై టైమ్ టేకెన్. ఇది కూడా ఉంది మనకు ఫార్ములా. రేట్ ఆఫ్ డిఫ్యూజన్ ఆఫ్ ఎనీ గ్యాస్ ఈజ్ గివెన్ బై ద ఫార్ములా వాల్యూమ్ ఆఫ్ ద గ్యాస్ డిఫ్యూజ్డ్ బై టైమ్ టేకెన్. ఇక్కడ హౌ మచ్ ml యూ గాట్ ఫర్ ఆక్సిజన్? 336 ml diffused in how much time? 1200 seconds. ఓకే, ఇది రేట్ ఆఫ్ డిఫ్యూజన్ ఆఫ్ ఆక్సిజన్. ఓకే, ఇప్పుడు రేట్ ఆఫ్ డిఫ్యూజన్ ఆఫ్ కార్బన్ డైఆక్సైడ్ మనం ఫైండ్ చేయాలి. దానికి వాల్యూమ్ సేమ్ రేట్ అంటున్నాడు, సేమ్ కండిషన్స్. కార్బన్ డైఆక్సైడ్, ఆక్సిజన్ సేమ్ రేట్తో డిఫ్యూజ్ అవుతున్నాయి, అంటే సేమ్ స్పీడ్తో బయటికి వెళ్ళిపోతున్నాయి. ఓకే, ఆక్సిజన్ అండ్ కార్బన్ డైఆక్సైడ్ ఆర్ డిఫ్యూజింగ్ ఇన్ ద సేమ్ రేట్. ఓకే, అంటే అన్ని సేమ్ కండిషన్స్ అంటున్నాడు, అంటే రేట్ ఆఫ్ డిఫ్యూజన్ రెండిటికి సేమ్ అని. ఓకేనా, గుర్తుపెట్టుకోండి. సో RO2 ఇఫ్ యూ టేక్ దిస్ వాల్యూ, CO2 ఫైండ్ చేయాలంటే వాల్యూమ్ మనకి తెలీదు. సో వాల్యూమ్ ఆఫ్ CO2 VCO2 అనే రాద్దాం. టైం సేమ్ కదా, సేమ్ కండిషన్స్ కదా. సో టైమ్ ఈజ్ 1200. ఓకేనా, 1200. సో ఇప్పుడు ఈ రెండు రేట్స్ సేమ్. ఓకే, దెన్ మనకి మాలిక్యులర్ వెయిట్ ఆఫ్ ఆక్సిజన్ యూనో, MO2 ఎంత చెప్పండి? 32. మోలార్ మాస్ ఆఫ్ ఆక్సిజన్ ఈజ్ 32 అండ్ మోలార్ మాస్ ఆఫ్ CO2 ఎంత నాన్న? 44. ఓకే, సో ఇప్పుడు మనం గ్రహామ్స్ లా యూజ్ చేస్తే వాట్ ఫార్ములా యూ విల్ యూజ్ హియర్? గ్రహామ్స్ లా యూజ్ చేద్దాం. సో RO2 బై RCO2 ఈజ్ ఈక్వల్ టు వాట్? ఫార్ములా ఫర్ గ్రహామ్స్ లా, R1 బై R2 ఈజ్ ఈక్వల్ టు M2 బై M1 కదా. సో M2 అంటే మాస్ ఆఫ్ CO2, మోలార్ మాస్ ఆఫ్ CO2 బై మోలార్ మాస్ ఆఫ్ ఆక్సిజన్. ఇక్కడ మోలార్ మాస్ ఆఫ్ CO2 ఎంత నాన్న? 44 బై 32. దిస్ ఈజ్ అండర్ రూట్. సో రేట్స్ ఆఫ్ డిఫ్యూజన్కి ఈ వాల్యూ వచ్చింది. అయితే రేట్ ఆఫ్ డిఫ్యూజన్ మనం వాడు ఏమడుగుతున్నాడు? ఎంత వాల్యూమ్ ఆఫ్ కార్బన్ డైఆక్సైడ్ కావాలి? రెండిటికి రేట్ ఆఫ్ డిఫ్యూజన్ సేమ్ ఉండాలంటే హౌ మచ్ వాల్యూమ్ ఆఫ్ కార్బన్ డైఆక్సైడ్ హ్యాస్ టు బి డిఫ్యూజ్డ్ అండర్ సేమ్ కండిషన్స్. అది మనకి కావాల్సింది. సో ఇప్పుడు మనం ఏం చేస్తాం? RO2 బై RCO2 ప్లేస్లో ఈ వాల్యూస్ వేసుకుంటాం. ఓకేనా, అప్పుడు 44 బై 32కి ఈక్వేట్ చేస్తాం. ఓకేనా, దెన్ యూ విల్ బీ గెటింగ్ ద వాల్యూమ్ ఆఫ్ CO2. ఓకే, జస్ట్ ఒక చిన్న లాజిక్ అప్లై చేయాలంతే. వాల్యూమ్ ఆఫ్ గ్యాస్ డిఫ్యూజ్డ్ బై టైమ్ టేకెన్ ఈజ్ ఈక్వల్ టు రేట్ ఆఫ్ డిఫ్యూజన్. ఓకేనా, గుర్తుపెట్టుకోండి. ఓకే, సో RO2 అంటే ఎంత నాన్న? 336 బై 1200. 336 బై 1200 బై RCO2 అంటే ఎంత? ఇక్కడ వాల్యూమ్ మనకు తెలియదు, మనం ఫైండ్ చేయాల్సింది ఏంటి? వాల్యూమ్ ఆఫ్ CO2. సో VCO2 బై 1200. ఇంకా ఈ అదర్ సైడ్ హౌ మచ్ వాల్యూ యూ గాట్? ఈజ్ ఈక్వల్ టు √44 బై 32. ఇక్కడ 1200 క్యాన్సిల్ చేయొచ్చు. ఓకే, సో న్యూమరేటర్స్ ఒక్కటి వేసుకుంటే ఎంత వస్తుంది? సింప్లిఫై చేసుకుంటే 336 బై VCO2 అంటే ఏంటి నాన్న? వాల్యూమ్ ఆఫ్ CO2 ఈజ్ ఈక్వల్ టు స్క్వేర్ రూట్ ఆఫ్ 44 బై 32. So VCO2 is equal to what? 336 into root 32 by root 44. సో ఇప్పుడు దీన్ని సింప్లిఫై చేస్తే మనకి ఎంత వాల్యూ వస్తుంది చూడండి, ఆల్మోస్ట్ అరౌండ్ 28.6 లీటర్స్ వస్తుంది. 28.6 లీటర్స్ వస్తుంది. సో దేర్ ఫోర్ వాల్యూమ్ ఆఫ్ CO2 డిఫ్యూజ్డ్ VCO2 ఎంత వస్తుంది నాన్న? VCO2 ఈజ్ ఈక్వల్ టు 28.6 లీటర్స్ డిఫ్యూజ్ అయిందనమాట. ఇఫ్ ఆక్సిజన్ అండ్ కార్బన్ డైఆక్సైడ్ ఆర్ హ్యావింగ్ సేమ్ రేట్స్. ఓకే, సో ఇలా ఉంటాయన్నమాట గ్రహామ్స్ లా ఆఫ్ డిఫ్యూజన్ మీద. దిస్ ఈజ్ వెరీ ఇంపార్టెంట్ ప్రాబ్లమ్. ఓకే, నెక్స్ట్ వీల్ మూవ్ ఆన్ టు 5th క్వశ్చన్ క్విక్లీ. Okay now dear children, please take screenshot or pause the video, keep writing and practicing. Okay, the more you write and practice, the best you will be getting marks. Okay, so next let us move on to the 5th question. For a monoatomic gas, monoatomic అంటే ఏంటి? అటామిసిటీ అండ్ ఈజ్ ఈక్వల్ టు 1 అనమాట. ఫర్ అ మోనో అటామిక్ గ్యాస్ కేఈ వాల్యూ ఏమో ఈ అని ఇచ్చాడు. కైనెటిక్ ఎనర్జీ ఈజ్ గివెన్ యాజ్ ఈ. ద రిలేషన్ విత్ ఆర్ఎంఎస్ వెలాసిటీ ఈజ్ హౌ మచ్? ఫైండ్ ద రిలేషన్ విత్ ఆర్ఎంఎస్ వెలాసిటీ. మోనో అటామిక్ గ్యాస్కి కేఈ వాల్యూ ఏమో ఈ అంట. ద రిలేషన్ ఆఫ్ కేఈ with RMS velocity, the relation of KE with RMS velocity. RMS velocity తో KE కి రిలేషన్ ఏంటి? ఈజ్ డాష్. ఓకేనా, మోనో అటామిక్ గ్యాస్కి KE ఏమో ఈ, దాని RMS వెలాసిటీకి ఫార్ములా అడుగుతున్నాడు. సో 4 ఆప్షన్స్ వాట్ ఆర్ గివెన్? RMS velocity విల్ రిప్రజెంట్ విత్ వాట్? URMS అని రిప్రజెంట్ చేయొచ్చు, లేకపోతే U అని పెట్టొచ్చు. సో ఆప్షన్స్ ఏంటి? ఆప్షన్ ఏ ఈజ్ 2E by capital M whole power half. ఆప్షన్ బి 3E by U ఈజ్ ఈక్వల్ టు 3E by 2M whole power half. ఆప్షన్ సి U ఈజ్ ఈక్వల్ టు E by 2M. ఓకేనా, E by 2M whole power half. ఆప్షన్ డి వచ్చేసి U ఈజ్ ఈక్వల్ టు E by 3M whole power half అని ఇచ్చాడు. సో దీంట్లో మనం కైనెటిక్ ఎనర్జీకి ఆర్ఎంఎస్ వెలాసిటీకి రిలేషన్ ఫైండ్ చేయాలి. ఓకేనా, క్వశ్చన్ ఏంటి నాన్న? ఫైండ్ ద రిలేషన్ ఆఫ్ కేఈ విత్ ఆర్ఎంఎస్ వెలాసిటీ ఈజ్ డాష్. ఓకేనా, మనం ఏం చేయాలి? వీ హ్యావ్ టు ఫైండ్ ద రిలేషన్ బిట్వీన్ ఆర్ఎంఎస్ వెలాసిటీ అండ్ కైనెటిక్ ఎనర్జీ ఆఫ్ దట్ గ్యాస్. ఓకేనా, మీకు అందరికీ తెలుసు కదా ఫార్ములా ఫర్ ఆర్ఎంఎస్ వెలాసిటీ ఈజ్ వాట్? వాట్ ఈస్ ద ఫార్ములా ఫర్ ఆర్ఎంఎస్ వెలాసిటీ ఇన్ టర్మ్స్ ఆఫ్ కైనెటిక్ ఎనర్జీ? మనకి ఫార్ములా ఇన్ టర్మ్స్ ఆఫ్ కైనెటిక్ ఎనర్జీ కావాలి. ఓకే, మనం చేసి చూసుకుందాం. ఓకే, సో ఇక్కడ ఏం చేయాలి? ఆర్ఎంఎస్ వెలాసిటీ ఫార్ములా చెప్పండి. URMS ఈజ్ ఈక్వల్ టు రూట్ 3RT/M. ఇది మనకు తెలిసిన ఫార్ములా. ఓకేనా, రూట్ 3RT/M. ఓకే, లేకపోతే రూట్ 3PV/M అని కూడా రాయొచ్చు కదా. ఓకే, రూట్ 3PV/M ఇది మనకి తెలిసిన ఫార్ములా. ఓకే, ఇప్పుడు మనం కైనెటిక్ గ్యాస్ ఈక్వేషన్ తీసుకుందాం అనుకోండి. PV ఈజ్ ఈక్వల్ టు వాట్? NRT. ఇక్కడ R బదులు మనం K తీసుకుంటాం. వాట్ ఈస్ K? K అనేది బోల్ట్జ్మాన్ కాన్స్టెంట్. ఓకేనా, డిడ్ యూ రిమెంబర్? R ఫర్ 1 mole ఆఫ్ ఎనీ గ్యాస్. ఓకే, సో ఇక్కడ ఇఫ్ యూ టేక్ N వాల్యూ ఈజ్ ఈక్వల్ టు 1, దెన్ R కెన్ బి టేకెన్ యాజ్ K విచ్ ఈస్ కాల్డ్ యాజ్ వాట్? బోల్ట్జ్మాన్ కాన్స్టెంట్. ఇది మీకు గుర్తు రావాలి. బోల్ట్జ్మాన్ కాన్స్టెంట్. R/Nని మనం బోల్ట్జ్మాన్ కాన్స్టెంట్ అంటాం. ఓకేనా, 1.38 into 10⁻23 moles per లీటర్స్. బోల్ట్జ్మాన్ కాన్స్టెంట్ అంటే ఏంటి నాన్న? R/N వాల్యూ, రేషియో ఆఫ్ యూనివర్సల్ గ్యాస్ కాన్స్టెంట్ విత్ ఎవగాడ్రో నంబర్. ఓకే, సో దాన్ని మనం కేతో రిప్రజెంట్ చేసామనుకోండి, N వాల్యూ 1 అయింది, R బదులు K పెట్టుకున్నాం. సో పీవీని ఎలా రాయొచ్చు? 1 ఇంటూ N ప్లేస్లో 1 వేసుకున్నాను, R ప్లేస్లో K వేసుకుంటాను. T ఈజ్ యాజ్ ఇట్ ఈస్, T సేమ్ రాస్తున్నాం. సో పీవీ ఈజ్ ఈక్వల్ టు KT అని రాసుకోవచ్చు. ఓకేనా? ఓకేనా డియర్ చిల్డ్రన్? పీవీ ఈజ్ ఈక్వల్ టు వాట్? KT. యాక్చువల్గా అయితే NKT, N1 వేసుకుంటే KT వేసుకోవచ్చు. సో ఇప్పుడు ఇక్కడ పీవీ ప్లేస్లో మనం KT వేసుకుంటాం. సో URMS ఈజ్ ఈక్వల్ టు 3KT బై క్యాపిటల్ M. దిస్ ఈజ్ అండర్ స్క్వేర్ రూట్. ఓకే, 3KT బై క్యాపిటల్ M. ఇప్పుడు మనం ఏంటి, కైనటిక్ ఎనర్జీని KEని ఈగా తీసుకోవాలి. ఓకేనా? కైనటిక్ ఎనర్జీ KE కెన్ బి టేకెన్ యాజ్ E. ఓకేనా? కైనటిక్ ఎనర్జీకి ఫార్ములా గుర్తు తెచ్చుకోండి. వాట్ ఈస్ ద ఫార్ములా ఫర్ కైనటిక్ ఎనర్జీ ఆఫ్ అ గ్యాస్? KE ఈజ్ ఈక్వల్ టు, ఇట్ ఈస్ గివెన్ బై ద ఫార్ములా 2/3 KT. గుర్తుందా? మళ్ళీ ఇక్కడ ఏం రాసుకుంటాము? యూ హ్యావ్ టు రికాల్ దిస్. వీ నో దట్, ఆర్ రికాల్ అని రాసుకోండి. రికాల్ KE ఈజ్ ఈక్వల్ టు వాట్? ఫార్ములా ఫర్ కైనటిక్ ఎనర్జీ ఈజ్ ఈక్వల్ టు 3/2 KT. గుర్తుందా చిల్డ్రన్? ఓకేనా? KE ఫార్ములా నాన్న ఇది. ఓకే, సో KE ప్లేస్లో మన క్వశ్చన్లో ఏమి ఇచ్చాడు? E రాసుకోమన్నాడు. సో E ఈజ్ ఈక్వల్ టు 3/2 KT. క్రాస్ మల్టిప్లై చేయండి. 2E ఈజ్ ఈక్వల్ టు 3 KT. ఓకేనా? అంటే ఇప్పుడు KT వాల్యూ ఎంత వస్తుంది నాన్న? 2E/3 వస్తుంది కదా. K ఇంటూ T ఈజ్ ఈక్వల్ టు 2E/3 వస్తుంది. ఓకేనా? K ఇంటూ T వాల్యూ ఎంత వస్తుంది? 2E/3 వస్తుంది. ఓకే, సో ఇప్పుడు ఈ RMS ప్లేస్లో, ఈ KT ప్లేస్లో ఇక్కడ వచ్చిన KT కావాలనుకుంటే దీన్ని ఈక్వేషన్ 1 అనుకోండి. నౌ దిస్ యూ విల్ టేక్ ఇట్ యాజ్ ఈక్వేషన్ 2. ఇప్పుడు ఈక్వేషన్ 1 KT ప్లేస్లో మనం 2E/3 వేసుకుంటాం. ఓకేనా? సబ్స్టిట్యూట్ ఈక్వేషన్ 1 ఇన్ ఈక్వేషన్ 2 ఇన్ 1. సబ్స్టిట్యూట్ చేయండి. ఓకేనా? రబ్ చేయాలా? అక్కడ రబ్ చేస్తాను చూడండి. ఇది ఈక్వేషన్ 1, ఇది ఈక్వేషన్ 2. KT ప్లేస్లో మనం ఏం వేసుకోవాలి? 2E/3 వేసుకోవాలి. ఓకే, కొంచెం కాన్సన్ట్రేషన్తో చేస్తే అన్ని సమ్స్ బాగా వస్తాయి. ఓకే, సో URMS ప్లేస్లో, KT ప్లేస్లో నేను ఏం సబ్స్టిట్యూట్ చేస్తున్నా? 2E/3 సబ్స్టిట్యూట్ చేయాలి. సో 3 ఇంటూ 2E/3, KT బదులు 2E/3 వేసుకుంటున్నా ఇక్కడ. ఓకే, హోల్ బై ఏంటుంది నాన్న? క్యాపిటల్ M. అండ్ దిస్ ఈజ్ అండర్ స్క్వేర్ రూట్. ఈ 3 క్యాన్సిల్ చేసేస్తాం. దెన్ వాట్ యూ విల్ గెట్? రూట్ 2E/m వచ్చింది. స్క్వేర్ రూట్ని మనం ఎలా రాసుకోవచ్చు? పవర్ హాఫ్ అని రాయొచ్చు కదా. సో RMS వెలాసిటీకి కైనటిక్ ఎనర్జీకి ఇప్పుడు మనకి రిలేషన్ వచ్చేసింది. ఓకేనా? జస్ట్ చెక్. URMS ఈజ్ ఈక్వల్ టు రూట్ 2E/M అని వచ్చింది. చూడండి, ఇది RMS వెలాసిటీ, ఇదేమో కైనటిక్ ఎనర్జీ. దానికి రెండింటికి రిలేషన్ వచ్చేసింది. ఓకే, సో లైక్ దట్. సో దిస్ క్యాన్ బి రిటన్ యాజ్ వాట్? 2E/M హోల్ పవర్ హాఫ్. సో ఇప్పుడు మనకి ఇచ్చిన ఆప్షన్స్లో ఈ ఆప్షన్ ఎక్కడుందో చూడండి. ఆప్షన్ ఏలో ఉంది. సో ఆన్సర్ ఈజ్ వాట్? ఆన్సర్ ఈజ్ ఆప్షన్ ఏ. ఓకే, సో రిలేషన్ బిట్వీన్ కైనటిక్ ఎనర్జీ అండ్ RMS వెలాసిటీ అంటే డైరెక్ట్గా ఈ ఫార్ములాను కూడా మనం గుర్తుపెట్టుకోవచ్చు. ఓకే, ప్లీజ్ చెక్. రైట్, నౌ విల్ గో ఫర్ ద 6th క్వశ్చన్. క్వశ్చన్ నెంబర్ 6. ఓకే, క్వశ్చన్ నెంబర్ 6. ఈక్వల్ అమౌంట్స్ ఆఫ్ 2 గ్యాసెస్. క్వశ్చన్ నెంబర్ 6 చూడండి. ఈక్వల్ అమౌంట్స్, ఇవన్నీ కంపల్సరీగా ఎంసెట్లో వచ్చే క్వశ్చన్స్. సో యూ హ్యావ్ టు కాన్సన్ట్రేట్ ఆన్ దిస్ కైండ్ ఆఫ్ క్వశ్చన్స్. ఈక్వల్ అమౌంట్స్ ఆఫ్ 2 గ్యాసెస్. నేను క్వశ్చన్ కూడా రాస్తున్నాను, వీడియో కొంచెం లెంగ్దీ అయినా కానీ ప్లీజ్ రైట్ అండ్ ప్రాక్టీస్. ఓకే, ఈక్వల్ అమౌంట్స్ ఆఫ్ 2 gases of molecular weights 4, చూడండి molecular weights 4 and 40, ఈక్వల్ అమౌంట్స్ ఆఫ్ 2 gases of molecular weights 4 and 40 are mixed. 2 గ్యాసెస్ని మిక్స్ చేశారంట. ఓకే, ఒకదానికి molecular weight 4 and the second one is having molecular weight 40. The pressure of the mixture is 1.1 atmospheres. ఓకేనా, the pressure of the mixture అంటే total pressure of the mixture, gaseous mixture అన్నమాట. The pressure of the mixture ఎంత ఇచ్చాడు? 1.1 atmospheres. ఓకేనా, what will be the partial pressure of lighter gas? అది question. What will be the partial pressure of lighter gas? ఓకేనా, what will be the partial pressure of lighter gas? ఒకసారి చూడండి. ఓకే, ఇక్కడ లైటర్ గ్యాస్ ఏది? హ్యావింగ్ 4 మాలిక్యులర్ వెయిట్ 4 దేనికి ఉందో అదే లైటర్ గ్యాస్. ఓకే, సో లైటర్ గ్యాస్కి పార్షియల్ ప్రెషర్ ఫైండ్ చేయాలి మనం. వీ హ్యావ్ వన్ ఫార్ములా. దిస్ ఈజ్ అకార్డింగ్ టు విచ్ లా? ఎస్, డాల్టన్స్ లా ఆఫ్ పార్షియల్ ప్రెషర్. సో అందులో మనం ఏం చేస్తాం? ఫార్ములా పార్షియల్ ప్రెషర్ ఈజ్ ఈక్వల్ టు టోటల్ ప్రెషర్ ఇంటూ మోల్ ఫ్రాక్షన్. ఆ ఫార్ములా యూజ్ చేయాలి ఇక్కడ. ఓకే, సో ఇక్కడ మోల్ ఫ్రాక్షన్ ఇవ్వలేదు. మనం ఏం చేయాలి? మోల్ ఫ్రాక్షన్ ఫస్ట్ వీ హ్యావ్ టు ఫైండ్. ఓకే, ఫస్ట్ మనం ఏం ఫైండ్ చేయాలి? మోల్ ఫ్రాక్షన్ ఆఫ్ లైటర్ గ్యాస్ ఫైండ్ చేయాలి. చూడండి, క్వశ్చన్ కరెక్ట్గా అర్థం చేసుకోండి. 2 గ్యాసెస్ ఆర్ మిక్స్డ్, టోటల్ ప్రెషర్ ఏమో 1.1 atmospheres, పార్షియల్ ప్రెషర్ ఆఫ్ లైటర్ గ్యాస్ మనం ఫైండ్ చేయాలి. ఓకే, సో we know that partial pressure is equal to what? We know that partial pressure is equal to total pressure into mole fraction. Okay na, total pressure into what? Mole fraction. Total pressure into ని డాట్ లాగా రాస్తున్నా. మోల్ ఫ్రాక్షన్ మీకు తెలుసు కదా, xi, మోల్ ఫ్రాక్షన్ ఆఫ్ లైటర్ గ్యాస్. ఓకే, మనం x1 అనుకుందాం. లైటర్ గ్యాస్ x అంటే ఫస్ట్ గ్యాస్ అనుకుందాం, హెవియర్ గ్యాస్ సెకండ్ గ్యాస్ అనుకోవచ్చు. ఓకే, టోటల్ ప్రెషర్ ఇంటూ మోల్ ఫ్రాక్షన్. సో ఇప్పుడు మోల్ ఫ్రాక్షన్ మనం ఫైండ్ చేయాలి. పార్షియల్ ప్రెషర్ ఆఫ్ లైటర్ గ్యాస్ కావాలి. సో x1 వీ హ్యావ్ టు ఫైండ్. x ఆర్ యూ కెన్ రీడ్ ఇట్ యాజ్ xi, ఎలా అయినా ప్రొనౌన్స్ చేయొచ్చు. సో x1 ఫైండ్ చేయాలనుకుంటే n1/n1 ప్లస్ n2. n1 అంటే ఏంటి? నంబర్ ఆఫ్ మోల్స్ ఆఫ్ లైటర్ గ్యాస్. n2 అంటే నంబర్ ఆఫ్ మోల్స్ ఆఫ్ హెవియర్ గ్యాస్. ఇప్పుడు నంబర్ ఆఫ్ మోల్స్ ఫైండ్ చేయాలంటే మళ్ళీ ఫార్ములా ఏంటి? గివెన్ వెయిట్ బై గ్రామ్ మాలిక్యులర్ వెయిట్. గివెన్ వెయిట్ బై గ్రామ్ మాలిక్యులర్ వెయిట్ ఆర్ మోలార్ మాస్. గివెన్ వెయిట్ మనకు తెలుసు, లైటర్ గ్యాస్ వెయిట్ మాత్రమే ఇచ్చాడు. ఓకే, గ్రామ్ మాలిక్యులర్ వెయిట్ ఈక్వల్ అమౌంట్స్ ఆఫ్ 2 gases. ఓకే, మాలిక్యులర్ ఈక్వల్ అమౌంట్స్ ఆఫ్ 2 gases. మాలిక్యులర్ వెయిట్సే ఇచ్చాడు 4 అని. గివెన్ వెయిట్ x అనుకుందాం. ఓకే, అలాగే n2కి ఎంత? గివెన్ వెయిట్ x, మాలిక్యులర్ వెయిట్ వచ్చేసి 40. ఓకేనా, హెవియర్ గ్యాస్ ఇది. ఓకే, సో ఇప్పుడు మోల్ ఫ్రాక్షన్ ఆఫ్ x1 ఫైండ్ చేయాలంటే ఈ ఫార్ములా సబ్స్టిట్యూట్ చేయాలి. x/4 హోల్ బై x/4 ప్లస్ x/40. ఇది మనం సింప్లిఫై చేయాలి. ఓకే, న్యూమరేటర్ అలాగే రాసుకోండి. x/4 హోల్ బై 4కి 40కి ఎల్సిఎం తీసుకుంటే 40 వస్తుంది. సో 4 10s are 40. సో 10x ప్లస్ x అంటే x/4 హోల్ బై 11x/40 ఉంది. ఓకేనా, x/4 బై 11x/40. ఓకేనా, సో ఈ క్వశ్చన్ నేను రబ్ చేస్తున్నా, ప్లీజ్ చెక్. ఓకే, సో ఇప్పుడు మోల్ ఫ్రాక్షన్ హౌ మచ్ యూ గాట్ డియర్ చిల్డ్రన్? x/4 ఇంటూ 40/11x. ఓకేనా, సో x క్యాన్సిల్ చేసుకుంటే ఇదేమో 4 1s are 4 10s are. మనకి మోల్ ఫ్రాక్షన్ ఎంత వచ్చింది నాన్న? 10/11 వచ్చింది. ఓకే, సో మోల్ ఫ్రాక్షన్ ఆఫ్ లైటర్ గ్యాస్ డైరెక్ట్గా రాసుకోండి. ఇక్కడ x1 అంటే ఏంటి? మోల్ ఫ్రాక్షన్ ఆఫ్ లైటర్ గ్యాస్, దట్ ఈజ్ ఈక్వల్ టు హౌ మచ్? 10/11. సో ఇప్పుడు మనకు పార్షియల్ ప్రెషర్ ఆఫ్ లైటర్ గ్యాస్ కావాలి. ఓకే, సో పార్షియల్ ప్రెషర్ ఈజ్ ఈక్వల్ టు టోటల్ ప్రెషర్ మనకి ఎంత ఇచ్చాడు, టోటల్ ప్రెషర్ ఈజ్ గివెన్ యాజ్ 1.1 atmospheres. చూడండి నాన్న క్వశ్చన్లో చూడండి 1.1 ఇచ్చాడు టోటల్ ప్రెషర్. మోల్ ఫ్రాక్షన్ మనం ఫైండ్ చేసాం, మోల్ ఫ్రాక్షన్ మనకి ఎంత వచ్చింది 10/11 వచ్చింది. ఓకే, సో ఈ 1.1ని 11/10 అని రాసుకోవచ్చు కదా. సో యూ విల్ రైట్ లైక్ దట్ and it gets simplified like this. 11 gets cancelled, 10 gets cancelled, 1. So partial pressure of lighter gas మనకి ఎంత వచ్చింది 1 atmosphere. ఓకేనా, therefore partial pressure of lighter gas is 1 atmosphere. అది ఆన్సర్. ఓకేనా, లైటర్ గ్యాస్ హెవియర్ గ్యాస్ అలా అంటాడు క్వశ్చన్లో, లేకపోతే డైరెక్ట్గా గ్యాస్ వాల్యూస్ కానీ లేకపోతే గ్యాసెస్ నేమ్స్ కానీ కూడా ఇవ్వచ్చు. ఓకే, సో దిస్ ఈజ్ యువర్ ఆన్సర్, క్వశ్చన్ నెంబర్ 6. ఓకే, నౌ లెట్ us మూవ్ ఆన్ టు ద క్వశ్చన్ నెంబర్ 7. Please note down each and every question, dear children. All the 10 sums which we are learning, which we are giving here are very much important in the examination point of view. Okay na, simple ga తీసుకోకండి, please take it seriously everybody. Okay, and we will be helping you in all the ways which we can. If you are kindly cooperating with us, even though length of the video may be a little bit longer, ఒకవేళ వీడియో లెంగ్త్ పెద్దగా ఉన్నా కూడా ప్లీజ్ బేర్ చేసుకుంటూ పాజ్ చేసుకుంటూ క్వశ్చన్స్కి ఆన్సర్స్ అన్నీ నోట్ చేసుకుంటూ లెర్న్ చేస్తే డెఫినెట్లీ యూ విల్ బీ సీయింగ్ సక్సెస్ ఇన్ యువర్ కాంపిటేటివ్ ఎగ్జామ్స్. ఓకే, సో నాకు మీరందరు చేయాల్సింది ఏంటంటే ప్లీజ్ సపోర్ట్ మీ by subscribing to my channel. Okay, right, so let us move on to the 7th question. Question number 7 చూడండి నాన్న. Equal amounts of gases are kept in 2 separate containers. చూడండి, ఈక్వల్ అమౌంట్స్ ఆఫ్ గ్యాసెస్ ఇచ్చాడు. ఈక్వల్ అమౌంట్స్ ఆఫ్ గ్యాసెస్ ఆర్ kept in 2 separate containers. Okay, equal amounts of gases are kept in 2 separate containers. If densities of 2 gases are in the ratio 1:2, if densities are in the ratio, if the densities of 2 gases are in the ratio 1:2 and pressures ఏ రేషియోలో ఉన్నాయి, టెంపరేచర్స్ ఆర్ ఇన్ రేషియో 2:1. టెంపరేచర్స్ ఫుల్గా రాయట్లేదు, టెంపరేచర్స్ ఆర్ ఇన్ ద రేషియో 2:1. ఓకే, ఆర్ ఇన్ ద రేషియో 2:1. అప్పుడు క్వశ్చన్ ఏంటి, క్యాల్కులేట్ ద రేషియో ఆఫ్ దేర్ ప్రెషర్స్. ఇది మనకి క్వశ్చన్. Calculate the ratio of their pressures. ఓకే, సో ఇప్పుడు మనకి ఒక రిలేషన్ గుర్తు రావాలి. డెన్సిటీస్కి, టెంపరేచర్స్కి, ప్రెషర్స్కి ఏమైనా రిలేషన్ ఉందా? ఓకే, క్యాలిక్యులేట్ ద రేషియో ఆఫ్ దేర్ ప్రెషర్స్. ఆప్షన్స్ ఏమి ఇచ్చాడు, 1:1, 1:2, 2:1, 4:1. ఆప్షన్స్ 1:1, 1:2, 2:1, 4:1, 2:1, 4:1. సో ఇప్పుడు మనకి ఏంటి అడుగుతున్నాడు, డెన్సిటీస్ రేషియో ఇచ్చాడు, టెంపరేచర్స్ రేషియో ఇచ్చాడు, ప్రెషర్ రేషియో కావాలి. సో ఈ మూడింటిని రిలేట్ చేస్తూ ఉన్న ఫార్ములా ఒకటి ఉంటుంది. అదేం ఫార్ములా, జస్ట్ రీకాల్ దట్ ఫార్ములా. ఓకే, సో సొల్యూషన్ చూడండి, మనకి ఏం ఫార్ములా ఉంది, వాడు ఏమి ఇచ్చాడు ఫస్ట్ అది రాసుకోండి. d1/d2 ఏమి ఇచ్చాడు నాన్న, 1/2. అలాగే T1/T2 ఎంత ఇచ్చాడు, T1/T2 2:1 ఇచ్చాడు. సో 2/1 అని ఇచ్చాడు. ఓకే, మనకేం తెలుసు, we know that density is directly proportional to pressure by temperature. ఓకేనా, అంటే డెన్సిటీ డైరెక్ట్లీ ప్రపోర్షనల్ టు ప్రెషర్ అండ్ ఇన్వర్స్లీ ప్రపోర్షనల్ టు టెంపరేచర్. అంటే దీన్ని బట్టి మనం ఏం రాయొచ్చు నాన్న, రిలేషను d1/d2 is equal to p1t2 by p2t1 అని రాయొచ్చు. అవునా కాదా, చెక్ చేసుకోండి. ఓకే, ఈ ఫార్ములా యూజ్ చేసుకోవాలి మనం ఇప్పుడు. ఓకే, ఇప్పుడు మనకు కావాల్సింది ఏంటి, P1/P2 కావాలి. అది ఒక్కటే సెపరేట్గా రాసుకోండి. P1/P2 ఈజ్ ఈక్వల్ టు D1T1/D2T2 అవుతుంది కదా, D2T2 అవుతుంది. సో ఇప్పుడు డైరెక్ట్గా వాడు ఇచ్చిన రేషియోస్ని క్రాస్ మల్టిప్లై చేసుకోవడమే. ఓకేనా, క్రాస్ మల్టిప్లై చేసుకుంటే ఆన్సర్ ఎంత వస్తుంది నాన్న, D1/D2 ఏమో 1/2, T1/T2 వచ్చేసి 2/1. సో క్రాస్ చేసేసుకుంటే 1:1 వస్తుంది. అంటే ఆప్షన్ ఎంత వస్తుంది, ఆప్షన్ ఈజ్ ఏ, ఆప్షన్ ఏ. ఓకే, మనకి డెన్సిటీస్కి, టెంపరేచర్స్కి, ప్రెషర్స్కి ఉండే రిలేషన్ అనమాట ఇది. ఈ ఫార్ములా గుర్తుపెట్టుకోవాలి. ఓకే, ప్లీజ్ రిమెంబర్ దిస్ ఫార్ములా. ఓకే, నౌ వీల్ గో ఫర్ క్వశ్చన్ నెంబర్ 8. Please take down, pause the video and note down, dear children. Okay, so question number 8. Okay, so question number 8 ఏంటి, ఫాస్ట్గా చేసుకుందాం మనం వితౌట్ ల్యాప్స్ ఆఫ్ టైం. ఓకే, చూడండి, ద మోస్ట్ ప్రాబబుల్ వెలాసిటీ ఆఫ్ ఎ గ్యాస్ అట్ 70 to 100 Kelvin. మోస్ట్ ప్రాబబుల్ వెలాసిటీ ఇస్తున్నాడు అంటే యూ మోస్ట్ ప్రాబబుల్ అని రాస్తున్నా. ఇది ఎంత ఇచ్చాడు, అట్ 70 to 100 Kelvin అంట. అట్ 70 to 100 Kelvin మోస్ట్ ప్రాబబుల్ వెలాసిటీ ఆఫ్ ఎ గ్యాస్ ఈజ్ ఈక్వల్ టు RMS వెలాసిటీ ఆఫ్ ఎ గ్యాస్ అట్ 27 degrees అంట. RMS మోస్ట్ ప్రాబబుల్ వెలాసిటీ at 70 to 100 Kelvin is equal to RMS velocity at 27 degrees centigrade. Just recall చేసుకోండి, 27 degrees centigrade అంటే ఎంత కెల్విన్, 300 Kelvin. ఓకే, ఇది ఇచ్చాడు కండిషన్. మనకి ఏం ఫైండ్ చేయాలి, ఆ గ్యాస్ ఏదో ఫైండ్ చేయాలి. ఓకే, విచ్ గ్యాస్ ఈజ్ హ్యావింగ్, విచ్ గ్యాస్ సాటిస్ఫైస్ దిస్ కండిషన్, which among the following gases satisfies this condition anta. Which among the following gases satisfies this condition. Okay na, most probable velocity 70 to 100 Kelvin దగ్గర ఎంత ఉందో RMS velocity of same gas కి 300 Kelvin దగ్గర అంతే ఉందంట. Most probable velocity is equal to RMS velocity. Okay, at different temperatures were given there. Okay, which gas is following that condition or which gas is satisfying that condition, that is your question. Okay, satisfying that condition, అది మనకి కావాలి. ఓకే, సో ఆప్షన్స్ ఏమి ఇచ్చాడు, వన్స్ చెక్ ఫర్ ద ఆప్షన్స్. ఆప్షన్ ఏ O2 CO N2, ఆప్షన్ సి N2 ఇచ్చాడు. ఆప్షన్ డి వాట్ హీ హెస్ గివెన్, SO2. ఓకే, మనకి ఇప్పుడు మాలిక్యులర్ వెయిట్ ఫైండ్ చేస్తే ఈ 4 గ్యాసుల్లో ఏ వాల్యూకి కరెక్ట్ మాలిక్యులర్ వెయిట్ వస్తుందో అదే ఆన్సర్ అవుతుంది. ఓకేనా, మనకి ఫార్ములాస్ తెలుసు కదా, జస్ట్ రీకాల్ ద ఫార్ములాస్ ఆఫ్ RMS వెలాసిటీస్ అండ్ రూట్ మీన్ స్క్వేర్ వెలాసిటీ. మోస్ట్ ప్రాబబుల్కి చూద్దాం, ఫస్ట్ సొల్యూషన్ తీసుకోండి. మోస్ట్ ప్రాబబుల్ వెలాసిటీ సొల్యూషన్ యూ మోస్ట్ ప్రాబబుల్ MP అని రాస్తున్నా. దానికి అట్ ఏంటి, టెంపరేచర్ ఎంత ఇచ్చాడు, 70 to 100 Kelvin ఇచ్చాడు. జనరల్గా ఫార్ములా ఏంటి గుర్తుపెట్టుకోండి, 2RT/M, 2RT/M. RMSకి ఇచ్చాడు ఏంటి ఫార్ములా, 3RT/M. ఓకేనా, మనం ఈ రెండు ఫార్ములాస్ గుర్తుపెట్టుకోవాలి. ఇక్కడ M వాల్యూ ఫైండ్ చేస్తే ఆ M వాల్యూ మాలిక్యులర్ మాస్ ఏ గ్యాస్కి ఉందో ఫైండ్ చేస్తే దాట్ ఓన్లీ విల్ బి యువర్ ఆన్సర్. ఓకే, సో యూ మోస్ట్ ప్రాబబుల్. ఇప్పుడు మనం స్క్వేర్ రూట్లు ఉన్నాయి కాబట్టి స్క్వేర్స్ చేసేసుకుంటే ఈ స్క్వేర్ రూట్లు తీసేయచ్చు. ఓకేనా, 2RT/M స్క్వేర్ రూట్ తీసేసాను, డైరెక్ట్గా ఇక్కడ స్క్వేర్స్ పెట్టాను అంటే స్క్వేరింగ్ ఆన్ బోత్ సైడ్స్ ఆల్సో యూ కెన్ డూ. 2RT/M ఈజ్ ఈక్వల్ టు వాట్, 3RT/M. ఓకే, ఇక్కడ ఇది M మళ్ళీ సేమ్ కావు కదా, రెండు డిఫరెంట్ గ్యాస్లు. ఓకే, సారీ M. ఓకే, M డిఫరెంట్ గ్యాసెస్ అంటే కండిషన్స్, టెంపరేచర్స్ ఆర్ డిఫరెంట్ కదా. ఓకే, ఆ వాల్యూకి టెంపరేచర్స్ డిఫరెంట్. సో వాట్ ఈజ్ ఓకే ఆర్ఎంఎస్ వెలాసిటీ ఆఫ్ హీలియం గ్యాస్ అని కూడా ఇచ్చాడు, ఈజ్ ఈక్వల్ టు URMS at 27 degrees ఫర్ హీలియం గ్యాస్ అని ఇచ్చాడు, ఫర్ హీలియం. ఓకే, అది కూడా ఇచ్చాడు క్వశ్చన్లో, జస్ట్ చెక్ చేసుకోండి. కరెక్ట్ దిస్ హీలియం అని కూడా ఇచ్చాడు, అంటే మాలిక్యులర్ వెయిట్ ఇచ్చేసాడు. ఆర్ఎంఎస్ వెలాసిటీలో ఉన్న మాలిక్యులర్ వెయిట్ ఇచ్చేసాడు. హీలియంకి మాలిక్యులర్ వెయిట్ ఎంత నానా? 4, అంటే ఇక్కడ 4 వేసుకోవచ్చు మనం. ఓకే, సో ఇప్పుడు M ఫైండ్ చేయాలన్నమాట. ఓకే, సో సబ్స్టిట్యూట్ ద గివెన్ వాల్యూస్. మనకి ఇచ్చిన క్వశ్చన్లో ఇచ్చిన వాల్యూస్ అన్నీ ఈ ఈక్వేషన్లో సబ్స్టిట్యూట్ చేయండి. R వాల్యూస్ ఎలాగూ క్యాన్సిల్ అయిపోతాయి. ఓకే, R గెట్స్ క్యాన్సిల్. 2T/M ఈజ్ ఈక్వల్ టు 3, ఇది T1, ఇదేమో T2. ఇక్కడ T1 వేసుకోండి, ఇక్కడ T2 వేసుకోండి. 3T2/4. T1 ఎంత? 7200 కెల్విన్ బై M వాల్యూ మనం ఫైండ్ చేయాలి. T2 ఎంత? 300 కెల్విన్ బై 4. ఓకే, సో ఇప్పుడు క్రాస్ మల్టిప్లై చేసి M1 వాల్యూ ఫైండ్ చేయాలి. ఓకే, సో M × 3 × 300 ఈజ్ ఈక్వల్ టు 2 × 4 × 7200. M వాల్యూ ఫైండ్ చేయాలంటే బ్రింగ్ దిస్ టు ద డినామినేటర్. 2 × 4 × 7200 బై 3 × 300. ఓకే, ఈ 0 zeros క్యాన్సిల్ చేసుకుందాం. ఇదేమో 3 3s are 9 అవుతుంది. సో 9 1s are 9, 8s are 72. అంటే ఏమేమి మిగిలింది అన్న? 2 × 4 × 8 మిగిలింది. 2 × 4 × 8, 2 4s are 8, 8 8s are 64. అంటే యూ గాట్ మాలిక్యులర్ వెయిట్ యాజ్ 64. మాలిక్యులర్ వెయిట్, మోలార్ మాస్ ఆఫ్ ద గ్యాస్ ఈజ్, ఓకేనా, మోలార్ మాస్ ఆఫ్ ద గ్యాస్ ఈజ్ ఈక్వల్ టు 64 వచ్చింది. ఇప్పుడు వాడు ఇచ్చిన 4 ఆప్షన్స్లో దేనికి 64 ఉంటుంది? జనరల్గా ఆలోచించండి, హెవియర్ కదా. 64 అనగానే సల్ఫర్ 32, ఆక్సిజన్ 32, 32 + 32 64. సో ఆప్షన్ ఏంటవుతుంది? ఆప్షన్ ఈజ్ డి, 64, విచ్ ఈజ్ ఈక్వల్ టు ద మోలార్ మాస్ ఆఫ్ SO2. సో ఆన్సర్ ఈజ్ డి, మోలార్ మాస్ ఆఫ్ SO2. అందుకే ఆన్సర్ ఏమవుతుంది నాన్న? ఆన్సర్ ఈజ్ డి. ఓకే, సో లైక్ దిస్ కైండ్ ఆఫ్ క్వశ్చన్స్ యూ విల్ బి గెట్టింగ్. ఓకే, నౌ లెట్ us క్విక్లీ మూవ్ ఆన్ టు ద రిమైనింగ్ 2 questions వెరీ ఫాస్ట్. వీడియో లెంగ్త్ కొంచెం ఎక్కువ అవుతుంది, ప్లీజ్ హోల్డ్ ఆన్ డియర్ చిల్డ్రన్. ఓకే, మధ్యలో వదిలేసి వెళ్ళిపోకండి, ఇట్ ఈస్ ఫర్ యువర్ బెనిఫిట్. ఓకే, వి ఆల్ ఆర్ వర్కింగ్ టుగెదర్, రైట్. 9th క్వశ్చన్ చూడండి. వాట్ ఈస్ ద రేషియో ఆఫ్ KE ఆఫ్ 7 grams of nitrogen and 4 grams of oxygen? And ratios of KE, ratio of KE of 7 grams of nitrogen and 7 grams of nitrogen and 4 grams of oxygen. 4 grams of O2 at T Kelvin. At T Kelvin. రేషియో ఆఫ్ కైనెటిక్ ఎనర్జీస్ ఫైండ్ చేయాలి మనం. ఓకే, KE అంటే ఏంటి? కైనెటిక్ ఎనర్జీ. కైనెటిక్ ఎనర్జీ ఫార్ములా, లెట్ us రికాల్ కైనెటిక్ ఎనర్జీ ఫార్ములా. ఇందాకలు కూడా వచ్చింది ఇదే ఫార్ములా. KE ఈజ్ ఈక్వల్ టు, వాట్ ఈస్ ద ఫార్ములా ఫర్ కైనెటిక్ ఎనర్జీ? 3/2 nRT. ఓకేనా, మామూలుగా చూడండి, గుర్తుపెట్టుకోండి, ఫార్ములా ఫర్ కైనెటిక్ ఎనర్జీ ఈజ్ 3/2 nRT. ఈ ఫార్ములాలో మనం అబ్జర్వ్ చేస్తే KE ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు N అనమాట. ఫ్రమ్ దిస్ యూ కెన్ సే దట్ KE ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు N. అంటే కైనెటిక్ ఎనర్జీ ఆఫ్ N2 బై కైనెటిక్ ఎనర్జీ ఆఫ్ O2 ఈజ్ ఈక్వల్ టు నంబర్ ఆఫ్ మోల్స్ ఆఫ్ N2 బై నంబర్ ఆఫ్ మోల్స్ ఆఫ్ O2 చేస్తే వచ్చేస్తుంది మనకి ఆన్సర్. నంబర్ ఆఫ్ మోల్స్ ఆఫ్ N2 హౌ మచ్? N2 ఎంత అవుతుంది? గివెన్ వెయిట్ ఏమో 7 grams, గ్రామ్ మాలిక్యులర్ వెయిట్ ఆఫ్ నైట్రోజన్ ఈజ్ హౌ మచ్? 14. N2 కాబట్టి ఇది 28, అంటే 1/4. అలాగే నంబర్ ఆఫ్ మోల్స్ ఆఫ్ ఆక్సిజన్ ఈజ్ హౌ మచ్ 4 grams by 32. మోలార్ మాస్ ఆఫ్ ఆక్సిజన్ ఈజ్ 32. సో 1/8. సో ఇప్పుడు ఈ రెండిట్లకి రేషియో తీస్తే మనకి ఎంత వస్తుంది? 1/4 హోల్ బై 1/8. ఓకేనా? 1/4 బై 1/8. ఓకే, సో ఆన్సర్ ఎంత వస్తుంది? 1/4 ఇంటూ 8/1 అవుతుంది. 1/4 ఇంటూ 8/1 విచ్ ఇస్ 2:1 వస్తుంది ఆన్సర్. ఓకేనా? 2:1. సో రేషియో ఈజ్ హౌ మచ్? 2:. రేషియో ఆఫ్ దేర్ కేఈస్, కైనటిక్ ఎనర్జీ రేషియో అడిగాడు. 2:1. ఓకేనా? రేషియో ఆఫ్ దేర్ కైనటిక్ ఎనర్జీస్ ఈజ్ వాట్? 2:1. ఇది మనకు గుర్తుపెట్టుకోవాల్సిన ఫార్ములా. కేఈ ఈజ్ వాట్? డైరెక్ట్లీ ప్రపోర్షనల్ టు నంబర్ ఆఫ్ మోల్స్. ఓకే, కైనటిక్ ఎనర్జీ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు వాట్? నంబర్ ఆఫ్ మోల్స్. ఓకే, సో అది 9th క్వశ్చన్. లెట్ us go to the 10th question. 10th question చూడండి నాన్న. ఇఫ్ కేఈ ఆఫ్ CH4, మళ్ళీ కైనటిక్ ఎనర్జీ మీదే. ఇఫ్ కేఈ ఆఫ్ CH4 ఓకే అట్ 7 Kelvin ఈజ్ X అంట. ఓకే, దెన్ కేఈ ఆఫ్ O2 at same temperature is how much? Then కేఈ ఆఫ్ oxygen at same temperature is how much? At same temperature is dash. ఓకే, ఆప్షన్స్ ఏమి ఇచ్చాడు? ఆప్షన్స్ AX, ఆప్షన్ B is 2X, ఆప్షన్ C is X², ఆప్షన్ D is X/2. ఓకే, ఆన్సర్ చెప్పండి. కేఈ అట్ సేమ్ టెంపరేచర్ అంటున్నాడు. రికాల్, మనం గుర్తుపెట్టుకోవాల్సింది ఏంటి? కేఈ ఈవెన్ డైరెక్ట్లీ ప్రపోర్షనల్ టు అబ్సల్యూట్ టెంపరేచర్ కూడా. రికాల్, కేఈ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు అబ్సల్యూట్ టెంపరేచర్. ఓకేనా? కేఈ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు అబ్సల్యూట్ టెంపరేచర్. ఓకే, సో మనకు ఆన్సర్ ఎంత వస్తుంది? టెంపరేచర్కి డైరెక్ట్లీ ప్రపోర్షనల్. సో అట్ సేమ్ టెంపరేచర్ అన్నప్పుడు కైనటిక్ ఎనర్జీ ఆల్సో సేమ్. ఇఫ్ కైనటిక్ ఎనర్జీ ఆఫ్ ఫస్ట్ గ్యాస్ ఈజ్ X, కైనటిక్ ఎనర్జీ ఆఫ్ ద సెకండ్ గ్యాస్ ఈజ్ ఆల్సో X ఓన్లీ. ఓకే, if temperature is same, if temperature is same, then KEs are also same. Okay na? KEs are also same. Okay, so answer is what? X. Okay, so ఈ మోడల్లో ఉంటాయండి మీకు న్యూమరికల్స్. ఓకే, ఐ హోప్ ఆల్ ఆఫ్ యూ ఆర్ ఫాలోయింగ్ మై ఛానల్. ఓకే, మీకు ఎలాంటి క్వశ్చన్స్ కావాలో కూడా మీరు కామెంట్స్లో పెడితే ఐ విల్ ట్రై మై బెస్ట్ టు మేక్ బెస్ట్ వీడియోస్. ఓకే, ఐ విల్ కీప్ సమ్ ఎఫర్ట్స్ ఫర్ యువర్ సేక్. ఓకే, అండ్ ఐ రిక్వెస్ట్ ఆల్ ఆఫ్ యూ టు ప్లీజ్ kindly subscribe to my channel and support me in my journey. Okay, thanks for watching. I always say your hard work is your superpower. Okay, thanks for watching. Bye.
If you like this video, you just like and subscribe the channel and share this video.